Hello, and welcome to Vector's Software Testing Symposium. My name is Jeffrey Fortin, and I'm one of the product managers for code testing here at Vector. In the next 20 minutes, I will show you the importance of unit testing in the software quality process. We'll talk about writing and running unit tests, and I will also show you how you can achieve world-class software quality in 3 simple steps. So at the beginning, I wanted to take some time to take a step back and really think about software quality and how it relates to the things that we do in our business. We all know that software is becoming more and more important for the products and the devices that we sell. A lot of the functionality that is in the device has been implemented in software. So the quality of that software really affects our business. And in fact, software quality is a real product differentiator. It's how we can separate ourselves from our competitors in the marketplace. And let's face it, if you have a buggy device, it just doesn't sell. So by focusing on quality and software quality and trying to improve that in the products and devices that you're making, you really can use that as a competitive advantage and use that to outpace your competition. The problem with quality is that it costs money. It's an investment. It's some expenditure that you have to put into your business. So we don't have infinite resources. So the magic is really to find an efficient way of implementing a quality process and doing quality improvement. And it's through that process that you will develop over time that you will actually get in front of your competition because your software quality will be high, your products will be well accepted in the marketplace, and you'll have a huge competitive advantage. So, why isn't our software quality better? We're all searching for that magic tool that's going to fix all of our quality problems. We just get this tool pointed at our software, and the next thing we know, all of the bugs are gone, and we finally have that high quality software and high quality product that we wanted from the beginning. Or maybe we're putting blame on the way that we're developing the software. We're using an old fashioned development paradigm. Nobody makes software like that anymore. That's why we've got so many problems in this software, is because we're using an old development paradigm. So we switch to a modern paradigm, and boy, this is going to solve all the problems. But the right answer really to that question is that it's through improved testing that we achieve improvements in our software quality. So it's by testing that we actually can measure the things that are in our software and measure against the key performance indicators that we have for our software and really prove out whether the software is meeting our requirements or not. So what does our unit testing process look like and what can we do to improve upon it? So with regard to writing unit tests, there are some guidelines, some best practices that are helpful and will really help to make that unit testing process much more efficient. When we write unit tests, we are testing a unit. So it's really important that that test isolate the unit under test. All of the things that surround that test case, or sorry, that unit, are things that we can control. All of the inputs into that, the global data, the parameters, all those things we want to have control over in the test harness itself. But the unit under test, we want to make sure that that's isolated. The reason for that is if we have a test failure, we don't want other software that's in the system affecting that test. We want to isolate that unit and just test that unit by itself. Now, unit, it's kind of a funny word because a unit can mean maybe a class or a method within a class or a function or maybe a group of functions. Usually, when we're talking about more than one function, we're talking about component testing or maybe integration testing. And component testing is actually a good way of thinking about unit testing. We might define a component to be an individual function, or we might define a component to be a collection of functions. And maybe it's the module interface itself or that we're trying to test. It doesn't really matter what the definition of the component is. What is important is that you define what the component is and that you're testing that component by itself, not with other components in the system. The test that we write for that component, we need to make sure that they test only one thing. And the reason why that's important is because when we have a test failure, we need to know what is broken. If a test tests multiple things, then it could be any one of those things that's actually broken. So we want to have a way of isolating in the test case what that test is testing. Also, we want to make sure that we have tests that test the requirements. It's the requirements that tell us what that unit should do. So if we have requirements and tests associated with those requirements, we have a way of validating the requirements and that the implementation of that unit meets what we intended for that unit to do. There are other types of tests that are automatically generated from the code themselves, or maybe non-functional tests, and those are fine. But from a quality process, quality is all about doing the things that we said that we would do. So the requirements are the things that tell us what this component should do or this unit should do. And we need to have a way of validating that the implementation of that unit does fulfill those requirements. Since we have requirements, it's really important that we have test cases associated with all of the requirements. That way we know that all of the requirements have been implemented in that unit. If there are some requirements that don't have test cases allocated to them, then we really don't know. We don't have any way of measuring if if that requirement ever got implemented in the unit. But we know requirements do change over time. So we need to also have a way of automatically tracking changes to the requirements and what test cases are affected by that. So if we have a way of automatically identifying a test case based on a changed requirement, then we can just go into our test editor. I see immediately what all of those tests are, and then revalidate them and mark them in some way to say that, yes, this requirement has changed. I've taken a look at the test case itself, and I confirm that the changes I made now match what the new requirement is, or maybe that there were no changes required. So now we've got all of our test cases identified. We've got all the requirements. We've allocated test cases to requirements. We know when requirements change, but it doesn't do anything unless we actually run those tests. When we're running unit tests, there are some things to keep in mind with regard to the quality process. And the first thing is to make sure that we can implement a common process for our entire project. The reasons for that are many, but we want to have some efficiency, like we said at the beginning, in our quality process. And if everyone's doing their own thing, then there isn't a lot of efficiency in that process. So any one of these things that they're doing can break, and we may not have the resources that know how to fix that particular thing. If we've got a common infrastructure, then we've got a common set of tools. People know how those tools work. If they transition from one group to another, they automatically know how to do unit testing. They don't have to learn a whole new process. If we find an error in that testing system, our IT system or whoever it is that takes care of the testing infrastructure that we have, they're familiar with it. They know what to look at. They know who to call, how to get things fixed. So there's a lot of efficiency that's built into having a common set of processes and tools. When we run unit tests, they tend to be a lot of them. And because of that, we want to make sure that we can run them in a very efficient way. And two key ways of improving that efficiency are parallelization and virtualization. By parallelization, what I mean is running all of the unit tests in parallel. So rather than sequentially unit test A, B, C, D, E, F, G, we want to run A, B, C, D, E, F, G all at the same time. It's through that parallelization that we get efficiency in the running of the tests. And by virtualization, what I mean is making sure that the test environment that we run the unit tests in is virtualized. And the reason for that is because we want to take it to scale. If in order to run a unit test, we rely on some scarce resource or some limited resource, then we have to wait or allocate or schedule that resource in order to run our unit tests. We just want to be able to run unit tests all the time. Ideally, what we'd like to be able to get to is a situation where we're writing code, we compile the code and immediately test it. Doing the test should be just as fast or maybe even faster than compiling the code. You certainly wouldn't go for days writing code without doing a compile. The compile is checking to make sure that you don't have syntax errors, etc., in the code, and it's a way of testing the code. Likewise, the tests that we have in our test harness should be run frequently as well, because as we're making changes to the code, we may inadvertently break something that was working before, and the tests will inform us of that, and we can keep the boundaries of what that unit is supposed to be doing. Unit test results need to be easy to understand. So once we've run these tests, we need to have a clear indication of it's passed or it's failed, one or the two. And since each test only tests one thing, we know immediately what it is that's broken. It's very helpful in our process if we have a way of publishing the test results to the entire team. The reason for that is so that we can see trends in those metrics that we're collecting. And also, it allows the project team as a whole to be able to understand where maybe more resources need to be applied, or maybe there's one team that's really doing well. They're able to achieve things much faster than anybody else. So they must have some best practices that the rest of the group could learn. If you have a test in your test harness that fails frequently, then get rid of it or improve it. A sporadically failing test gives you no information whatsoever. You won't trust it when it fails. You'll say, oh, it fails again. Sometimes that does that. Don't worry about it. If you've got a test like that, what's the reason for even running it to begin with? What you need to do is rewrite that test or just get rid of it because it's not improving the efficiency of your quality process at all. So now we've written the tests, we're running the tests, and now we need to understand how it is that we're going to take all these test results and figure out what to do with them. So if you have a quality process, one of the things that's important is to make sure that you identify for your project what are your key performance metrics? What are the things that are really important for your particular project? And different industries have different things, different companies have different things that they feel are important. And it's important to identify those right up front. And secondly, to be able to measure them. If you don't measure something, you have no way to improve upon it because you have no basis of knowing where you began. So if you have a starting point and then you're measuring that key performance index over time, then you can get the trend. The numbers themselves aren't so important. It's the trend of the numbers that really gives you a lot of information. So I've got some test metrics, some metrics down here of some things that you might want to consider for your key performance metrics. The first one being a test metric, test coverage metric. And by test coverage, what I mean is when you run a test case, it exercises certain lines of code or certain branches are taken. And it's that metric that gives us some understanding of how much of the code has actually been tested. It's a really enlightening metric, and it's nice because it sort of comes along for the ride. As we do the testing, we can collect the information about the coverage at the same time. So when we have this coverage information, it can give us a lot of information about what the tests are actually covering. If we've got legacy code, you might be shocked to find how much of the code actually isn't tested with the tests that you have for all of that legacy code. Um, it's enlightening at times. Also, if you're only relying on functional testing, so not unit testing or component testing, you're only doing functional testing, you're testing the application in its entirety, it's very rare to get to 100% code coverage with functional testing. So with unit testing, we can actually boost up the amount of coverage that we have in the system. So we have a certain amount that we've gotten from functional testing, and we can use unit tests to supplement that and improve the amount of code that we've actually are testing in the system. Your metric might be the ratio of passing tests to failing tests. Maybe it's not okay to have 100% passing tests, and this is really a decision that needs to be made for your particular project. There are some projects that won't deliver unless they have 100% passing tests. Others are willing to accept some tests that are not passing as acceptable, and they can still deliver even if they're not at 100%. Certainly, safety critical applications, especially with high integrity or things that are high levels of safety, high levels of safety integrity, they tend to be more conservative, so they won't ship until they reach these 100% numbers. So we have the metrics, we've measured them. So now we need a way to analyze all of those things. So when we analyze the results, we're making some decisions about, where are we, what's the trend over time, and what kinds of things can we do next time to make it better again. So develop a plan to improve upon the metrics that you have. If you have a coverage metric, then maybe your plan is to write more unit tests to improve that coverage. Maybe it's a code inspection and taking a look at the code itself and finding out if that code really is supposed to be there to begin with. That's another way to improve coverage. Not many people think about that, but if you have less code, then that's not covered, then you can improve your coverage metric that way. And it's valid. A lot of times we have code maybe that we inherited. We're not using any of that functionality. It's okay for it to not be covered, and we could just make the decision now that we have the information about whether we're going to keep it or not. The numbers that we have, the metrics that we have, only have value when we take a look at them over time. So I'll give you an example. If we collect for the first time a coverage metric, and we find that we are at 40% code coverage, well, we might be a little disappointed in that because we thought we had pretty good tests and we thought we would be closer to 100%. But what I'd say is don't worry about that 40% now. Measure again in whatever period you want, in a couple of weeks, a couple of months, whatever it is, and then see what it is now. And maybe you've gone from 40% to 50%. So that's a pretty good boost in code coverage. Maybe you've actually declined. So you've gone from 40% down. Maybe a lot of new code was added to the system. So you haven't been keeping pace on the test cases that have been added, and your code coverage actually went down. Maybe your metric that you have for this week is 40, but last week it was zero. Okay. So you went from 0 to 40. So now you're really happy. So the 40 number is really relative to where it is in the trend. Now, if you're starting with 40, then you really don't know what the trend is. But if you start at 0 and you move to 40, that gives you a lot of good information. So all of these metrics that we have and the metrics that we collect, we need to make sure that for them to have value, they need to be easy to collect. If they're not easy to collect, then they won't be collected, and we have no way to act upon them. So we need some way of automating the collection of all of these metrics, of providing that information so it's very clear, are we meeting our performance objectives or not? What is the quality of the system? Does it meet our quality criteria, et cetera? So there needs to be an automated and easy way for all of that information to be shared. Okay, so we've finished now talking about the writing and running unit tests, and we are going to get into our demo next. And in the demo, I'll be showing you VectorCast and how VectorCast can help us with our quality process and in helping us write and run tests efficiently. Okay, so if you haven't seen it, this is VectorCast. And here I have a class for car data. And one thing about this particular piece of code is it's riddled with bugs. So it's sort of a tester's amusement park. And of course, it makes for a good example. So we'll go through some of these things, but also it'll be able to show you how VectorCast is set up to very nicely implement the things that we talked about earlier. So the first thing I have is the constructor for this class, and I have also in VectorCast, I've imported the low-level requirements that I have for this particular unit under test. And I have 3 requirements actually so far. And I have some of the test cases that are needed to implement these requirements. This is one of them. And in this test case, we have a requirement for providing certain signals. And this is one of those signals for lock mode. And the lock mode has some states to it, and those states are actually listed right here in the enumeration. So the lock mode can be auto lock or manual lock. And you notice that VectorCast has actually parsed the information that's available to us in the code and easily shows us what the available values are for this particular enumeration. So that makes it very easy to write the unit test case. As I mentioned earlier, we want to make sure that the test case does only one thing, and that's what I have here. So I'm going to set up this test case to set an input value of manual lock, and then I'm expecting the object to have a value of manual lock when I come out. So I can take a look at the execution report for this, and it's very simple, very easy to understand. I can see that the input parameter here for manual lock has matched, and the expected value has come back correctly as well. A little summary down here at the end for the expected results, 100%. As you can imagine, green is a good color, so that's what we like to see for our unit test cases. All right, let's go on now to another unit test case. And in this case, the requirement that this test case is implementing has actually been updated. So I have a change in the requirement, and it can actually find these pretty easily in the system. It's telling me that this particular test case has two requirements associated with it, and both of them need to be reviewed. So here are the two right here, flagged red. Of course, red is bad. So that it says needs review right on there. So I can take a look at this updated requirement. That's actually two requirements here for the signals and for the methods. So I can take a look at that and revisit the test case itself and see if the input values that I have for this test are correct for this new updated requirement. And if everything looks fine, so no problems whatsoever, I can just go ahead and click this. Everything turns green. We like green. So that's an indication that I have reviewed that particular requirement and I have validated that the test case is accurate in regard to that requirement. So the other thing I wanted to show you is I've stressed the point that it was really important that when you test units that you isolate them. And one really nice thing that we have in VectorCast is we can actually stub out all of the other parts of this unit under test and make sure that they have no influence on the unit that we're testing. So I've stubbed them out and I've actually put in a special kind of test called control flow because this particular unit shouldn't be calling any other units outside of it. Everything should happen within the unit itself. So I have a way of validating also the isolation of this unit under test. If I did have other units, I could stub them out and provide mock inputs and outputs to them very easily. And if this unit was supposed to call out to other units, I could test that and make sure that it was calling those units and not any other units. So this is also a very handy way of seeing that we've got a unit under test that's completely contained, and I'm actually validating that through the control flow test right here. And you notice at the bottom here, it tells me as well that the control flow is matched. And so this brings me to the end of the presentation, unit testing done right. I hope I've given you some information that you can act on in your current project or your next project. When you do, please keep in mind these points. Software is a product differentiator, and software quality is how you can set yourself apart from your competitors. Software doesn't improve by wishful thinking. You need to take action and start improving your software quality process. And it's by improved testing. Improved testing is the best way to improve software quality. Identify what you want to improve, measure it, make adjustments, and iterate on the process. We'll be taking your questions next in the Q&A session. In the meantime, I thank you for joining me. It was a pleasure to talk with you today. Bye for now.